Okay. I asked you.
Oh yeah, yes, the 3 different structural isomers.
Right? Did I?
Yes.
I did.
I don't remember. I was kind of confused when I think
Nice. Okay. I'm curious. Just be honest because it's not going to matter if you say yes or no. It's not like the answer is not going to impact your grade or anything.
No.
Did you?
Yes.
Yeah, you did?
I only did 2.
Oh, okay. All right.
That's actually 2/3.
So let's
I did 66 of.
take a look at C5H12. What would you typically call that?
Something. Oh wait.
You would probably call that some version of pentane, right? So I've got pentane here. Pentane is just 5 carbons in a row, and it's got all hydrogens attached to it other than those 5 carbons. And so I'm going to draw, that's probably the first one, that's probably the most obvious one that people are going to draw. So we'll go... Oh man, this is already a huge pain in the butt.
That's why a lot of us didn't do it.
That's why a lot of you didn't do it.
I mean, I did 66% of the work required.
So you did less than the minimum standard that was required.
Yes.
Yeah, okay. As long as we're on the same page.
At least I did so.
Are we okay with this? This is pentane, right?
Yes, sir.
Now, what did I say? What's the easiest way to make a structural isomer?
Just like beautiful thing.
Take on the end.
So we're going to take off the end. So this last carbon, we'll take that off, and then we'll attach it to the middle of the compound. So I'll swap out that hydrogen. This is way harder than I thought it was. There we go. Perfect. So now, when you look at this, how many carbons are in my parent chain? Now we've got 4, right? We're basically taking this group of CH3 and we're going to swap it for that hydrogen. That's what we're going to do. So the next one will be 4 carbons in a row. And then on either the second or third carbon, right? So we'll put maybe on here. That's where we'll put our CH3. I'm gonna start doing condensed diagrams because structural diagrams are such a huge pain in the buttocks that I'm not going to do it. If Forrest Gump's allowed to say it, then I'm allowed to say it.
He shot me.
He shot me in the buttocks.
Forrest Gump also ran for no reason.
What?
Forrest Gump also just ran everywhere.
No, he ran because he needed time to think about his situation. Let's see. Let's think about this. Could I have taken that carbon and attached it to the very first carbon in my chain? Is that a possibility? Could I have taken that last carbon in the chain and pulled it out and swapped it for one of the hydrogens that's attached to the first carbon? So, okay, let's draw it. Let's draw it and let's see if there's a difference. So, how many carbons, when I take this and swap it there, how many carbons in my parent chain? 4. And then what's attached to that first carbon? So, how many carbons in my parent chain? 5. Does that make sense?
Yes.
Yeah. So you can never have a branch on the first or last carbon. Does that make sense? That's just not, it's nonsensical, it doesn't make sense. So if you ever have a branch on the first or last carbon, then that just is extending your you're extending your parent chain. Max.
So if you had like a straight line and then you took the 2 carbons off the end and put it on 2 and 3, like it made like a box with like 1 carbon going down. Is that illegal?
Okay, let's try it. So you're going to, let me think about this. You're going to take your 5 carbon chain, and what are you going to do?
Take the 2 off the back.
So we're going to take the 2 off the back end
and stack them on the next 2.
And stack them on. Are we separating them, or are both carbons going to go in?
Separating them. Like one's on 2, one's on 3.
So one's on 2 and one's on 3. Okay. Now let's think about that. What's our longest parent chain? 4 carbons, right? So is this any different from that? No, it's beyond the shadow of a doubt. It's no different at all. Because how many carbons in this parent chain? 4. How many carbons in this parent chain? 4. And then you have a 2-methyl, right? A methyl on carbon number 2. This is a methyl, and it's also on carbon number 2, right? Just that we're numbering it from that way. That's all.
So is that right?
So is this is a structural isomer. Once you fill in all the hydrogens, this totally is a structural isomer of that. But so far, we've only been able to make 1. This thing and that thing, they're the exact same thing. So we've only made 2 out of our 3 structural isomers. Mark? 1 carbon with a bunch of them around. Yeah. That's so good. How could you, let's talk about changing this into that new one. What could I do? Joe?
Take the 3rd carbon.
Take the 3rd carbon, the last one, right? And put it on top. So how many carbons in my parent chain? 3. So what's the name of this thing? I'm not going to fill in the hydrogens, but what's the name of this? What is it end in?
Right?
How many carbons in this parent chain? 3. So what's that? Nope. Propane.
Why don't you just say yes when I say it?
I'm trying to get other people to say it too. So this is going to be propane. And what branches do we have on our parent chain?
You have 2 methyls.
2 methyls. How do you say 2 methyls?
2 methyls.
Yeah, I would say dimethyl.
Oh, dimethyl. 2 dimethyl.
Yeah. So this is going to be 2, 2 dimethyl propane. Because both of these carbon branches are attached to the 2nd carbon, right? This is a 2-methyl, this is a 2-methyl, so 2,2-dimethyl propane. The name of our original compound was just pentane. What's the name of this? What's the name of this structure here?
2-methyl
It's start from the last. What's the parent chain? Butane, right? So this is for sure. I don't know what the hell that is, but so this is for sure going to be whatever. It's going to be butane for sure. And then we've got a methyl group attached to what? 2. So 2-methyl butane. 2-methyl butane. Is that okay? I've got an activity for you, if that's okay.
Oh no, Walton, you can't.
Okay. You're all right. So there's no paperwork really involved in it. Really involved.
I need to go run across Alberta real quick. I gotta think about this.
What I want you to do is I want you to grab a molecular model kit. Not yet. I want to grab a molecular model kit, and either you and your friend, you can work together, or you can just work on one your own. That's totally fine. And what I want you to do is I want you to make the chemical. What do you want to do? Do you want to do hexane or do you want to do heptane? Hexane. So I want you to make hexane, but then I want you to figure out I want you to figure out how many structural isomers of hexane there are. So I want you to make, number one, just make hexane. And you can, if you want to, you can just, you can forego all of the hydrogens. You can just make the 6 carbons in a row, that's fine. But then I want you to try and figure out how many isomers, yes I do, of hexane exist. So I want you to try and figure out how many different isomers of hexane can you make. Now, the key to figuring out if something is an isomer is that it's got the same molecular formula, so the same number of carbons and hydrogens and everything like that, but it has to have a different name. You have to name it a different name. Like here, do these 3 things have the same name? No, but they have the same chemical formula. They're all made up of C5 and 12 H's. So that's what I want you to do. I'm going to give you about 10 minutes to do this. Please, thank you. Go ahead. Hello.
I was gonna grab Why? Oh.
So for decade, C10, H2, how many would there be for decade? Yeah, you're making a series in your head, right? Yeah.
Am I right?
No.
No?
No. You might be right about hexane, you'll just have to figure it out. How much is it for 10?
Because he's got the same parents.
I think there are something like hey Joe.
Holy.
They were so
so I guess it's
It's like 2 dogs. Yeah.
Yep. It's like huge sense of
That would be scarred.
I never actually saw it.
It's gross. I never wanted it. Never do. It's disgusting.
So you have the one isomer, right? Just hexane, boom, that's one isomer. Okay, now what's this? What's this name? Your parent chain, how long is your parent chain? Pentane? Yep, and
two methylpentane.
2 methylpentane. Good, so that's 2 so far. Right? Is the 2 carbon, is that the only place you can put it?
This is it.
Put it in the 2 or the 3.
So put it on the 3, does that make it a different compound? Is it a different structure if you put it on the 3?
Not necessarily.
I don't know, tell me.
Because if you were to take this back away, take this right here. It's gonna go flying.
Yeah, that's fine.
Wait, do we not have a test on Friday?
I was like extra, but it's
Yeah. Did I say you guys were taking this? Yeah.
That doesn't look like
I want you to,
Either way, I'm not.
yeah. That's Cyclo.
this one doesn't Okay, so this is 3
How many hydrogens? You can't make a ring. Every time you make a ring, your change.
1, 2, 3, 4, 5. And the methyl is attached to the green, you know?
That's totally different from 2-methylpentane, right?
Yeah.
Totally different.
And you can't do it any different than this.
Yeah, that's the only way. That's using one switch. Those are the only 2 ways, right? Yeah, put them away.
This we have 2. Okay, so
I want how many you can get.
what if we went like
If you count the first one.
Yeah.
oh wait, this doesn't work.
Okay, so that's
Where does the it's like that doesn't work.
Oh, yeah, right. Don't worry. So, like, have you, like, not been I did it in 10
Yesterday, I was walking down the hallway and I'm like,
We would stare at it. Yeah. But like, I heard, like, did So bad, but it was so good.
That's why. Just take one from his side. You just take one in and just stick it in.
Okay, I'm curious how many people have been able to make, so for sure there's one isomer. What I mean by that is there's hexane, right? Okay, good. So everybody should have been able to make hexane. Okay, what about two isomers? What's the next isomer I could make here? I can make a pentane, so I'll take this last CH3 and I'll pop it onto somewhere. Where do you want to attach it to?
Number 2.
The number 2 or the number 3?
2.
Well, we could do both of those, right?
Sure, why not?
Sure, why not? So carbon, 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 or carbon, 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 carbon. So the carbon could either be attached to the 2 or the 3. Are these things the same thing? Is 2-methylpentane and 3-methylpentane, are they the same substance? No, they're not the same substance. They're isomers of each other, right? They have the same chemical formula, but they're not the same thing. So that's 3 isomers. Did anybody get a different isomer other than this? Okay, we can make butane. So, what could we do? We've got 2 carbons that we need to attach to places. Where can we put them? 2 and 3. We could put them on the 2 and the 3. So that would be 2,3-dimethylbutane, right? Okay. Is there any other way that we could make another isomer? How else could, instead of attaching the carbons to 2 and 3, what could I have done? I couldn't have done 1 and 4 because then it'd be 6 carbons long, right? I could put them on 2 and 2 or 3 and 3. Whoop. So is the name of this thing 3,3-dimethylbutane?
No.
This isn't 3,3-dimethylbutane. Why is this not 3,3-dimethylbutane? Yeah, because it's 2,2. 1, 2, 3, 4. It's 2,2. So 2,2-dimethylbutane. There are only 5 isomers of hexane. the more carbons you have on your molecule, the more isomers you can draw. And it's pretty complicated math, but the number rises very dramatically. So let's just Google isomers of pentane. Now, do you remember how many isomers of pentane there were?
What?
The hexane, there were 5. Pentane, there were only 3, right? So there are 3 known isomers of pentane. You can't get any more than that. Hexane, there are 5 isomers of hexane. Hexane, jeez. What about heptane? What if I would have given you heptane? There'd be 9. What about octane? There are 18 of them. What about nonane?
Is it just double?
Nope.
35.
There are 35 isomers of nonane. What about decane?
I'm not gonna guess.
70.
There are 75 isomers of decane. What about something like C25H52? How many isomers do you think there would be?
A lot.
There are thousands of them. Google it. Thousands of isomers. So these isomers, remember, if I take a methyl group from somewhere and add it to somewhere else, that becomes an isomer, right? And so the more carbons you have, the more combinations of different methyl groups that you can put on there. And so the math gets out of control really quickly because of that. Let's do some of this. Now that you are kind of aware of what isomers are, let's draw a structural isomer of the following compound: 3,6-diethyl-4-propyl-octane. Let's draw, first of all, let's just draw 3,6-diethyl-4-propyl-octane. What do you want to do? Do you want to draw a structural diagram, a condensed structural diagram, or do you want to draw a line diagram?
Line.
Hands up for a structural diagram.
Yeah.
Hands up for a structure or condensed structural diagram. Hands up for a line diagram. Condensed structural wins. So we're gonna do this as a condensed structural diagram. Yeah. So let's take a look at this. How would you draw this? Where are you gonna start?
The end.
At the end. What does the end mean?
It's the pair chain.
Octane. C, 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 C.
By the way, welcome for C25H52.
Yeah.
Has 62.5 times 10 to the 12 isomers.
62.5 times 10 to the 12.
Yeah.
So there are over 62 trillion combinations of C25H52. That's fantastic. I love that. Draw out all of the isomers of paraffin wax, please. Okay, so what am I going to do here? Let's draw this. Where am I going to put some branches? What's the first branch you want to put on there?
3.
The 3. What's going to go on the 3? 1 ethyl group, right? How many is an ethyl group? 2 carbons. So on the 3rd carbon, I'm going to put a 2 carbon group.
Well, how do we know that we want to put it there and start labeling it from there or at the end?
Doesn't matter. It doesn't matter. You can start from the left or start from the right. Just do it always the same way.
Okay.
Okay, so I'm putting an ethyl group there. Where else do you want to put an ethyl group? On 6. And then where else do you want to put any group?
4.
On 4, and what's going to go on 4?
3.
And then you just fill in, because I'm asking you for a condensed structural diagram, just write your H's, so CH2, CH3, CH, that kind of thing. Yeah.
No. 1, 2, 3, 4, 5, 6, 7, 8. Wait, did I count wrong? Yeah, I counted wrong.
Good talk. Yeah, we're good. Yeah.
So we know that the parent chain has 8 carbons in them, right?
Yep.
And it goes across like this. But now that we've added the 4 to the 4th one, can we go like this and then down?
So do you want your parent chain to go this way now?
No.
Is that what you're saying?
Well, no, other way.
What other way?
The other way. See, there's 1, 2, 4, 5, 6. Oh no, never mind. You were right. 1, 2, 3, 4.
But it's the same. It's the same.
Yeah. It's the same.
It's the same, right?
Is that, all right.
This is an 8 carbon parent chain. This is also an 8 carbon parent chain.
So it's cool if we like choose that to be our parent chain or something like that.
No, because that you don't know what the hell kind of group this is.
Okay.
So you just choose the parent chain that allows you to have the most branches.
Okay.
And then, but it should also be the longest parent chain.
Okay.
Okay. All right. Anyways, okay. So hopefully you have CH3, CH2, CH, H2, H3, H2, H2, H3, H3, H2, 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 H3. Yeah.
Can I say something unrelated?
Sure.
Why can I imagine a guy a long time ago sitting in a dark room on house arrest and being told to draw isomers?
I don't know, man. Because it seems like a big punishment to me.
Just like think about it.
Just like draw all of the isomers.
Like, you know how the kids like used to like be in detention, they'd have to write.
Yeah, they'd have to write lines, right?
Yeah, they just have to do isomers.
Hey, have you guys ever had to write lines before as detention?
No. Never had
Yeah,
to.
just detention. I've had to do it.
No, but in the past, have you ever had to write lines during
Oh, I like
detention?
that.
No, that's fine.
I'm a good child.
Yeah, that's right. Yeah. I'm just curious if anybody still did that practice. I can't imagine anybody would, but that's fine. Okay. Shh. So let's draw an isomer. Let's draw an isomer of this compound. What is an isomer of this compound?
Move everything 1 to the right.
What do you mean move everything?
All the ethyl groups.
Sure. Sure. Can we, is it okay if we move this alpha group, or sorry, one to the right or one to the left?
Whichever one you want.
Okay, whichever one you want. Okay, could we move this one to the right and this one to the right? Would that make a different compound?
Yeah.
Yes, it would. You can do, remember there's probably well over 1,000 different combinations of an isomer that we can make. How many total carbons are on here?
8. Oh, wait, no, that's not.
How many total carbons are on here?
Quite a bit.
15.
So could you just draw 15 carbons in a row, and would that be a structural isomer of this thing? Yeah, you could. If you wanted to, you can draw any structural isomer. This is just your, it's up to your creativity, that's all. So draw for me one structural isomer. Go ahead. Draw for me, what? Yeah, sure. As long as you don't draw the exact same thing, you're fine.
Oh, I'm fine.
Yeah.
Try to make a nose.
As long as it has the same number of carbons and the same number of hydrogens, then you'll be okay. Yeah, sure. That's a perfectly reasonable structural isomer, right?
Yes.
Totally. Yeah.
Wow.
Do you know why we're going through this process?
You can feed your family. It's a job.
So I'm doing this just so I get a pay. I'm doing this activity just so I get a
You
paycheck.
prepare us for the future.
Oh,
To
okay.
feed our, to feed
To
our.
be stuck
Okay,
in
well
a-
that is not
to
the
be-
way I thought
to be
somebody was
stuck-
going to answer
To
that.
be stuck in a dark room, having to do isomers like we do.
I was gonna say. When we need to do isomers to get our.
Oh, okay. Yeah.
Well, like,
Yeah. So 1, 2, 3, 4, 5, 6.
Did you guys all make it out? Well, did you guys all
This is
What?
3,
No,
5, 6, 7, 8, methyl, hexamethyl. Yeah. It's pretty. Okay, we're gonna move on. Okay. So what I want to talk about is, do you remember the formula for alkanes?
It's like spaghetti.
CnH2n plus 2. So if I had C3, how many H's should be on propane? 8. 2 times 3 is 6, plus 2 is 8. Good. Let's take a look at this. There are, this part is quite important. Yes. There are other ways that I can arrange 3 carbons where it doesn't follow this rule. And one of the ways that I can arrange 3 carbons is by doing something called a cyclic compound. Cyclic, what does that mean? A cycle, like a bicycle. What is a bicycle? 2 wheels. 2 wheels. That's all it is, right? What is a unicycle? One wheel. One wheel. A one. What is a tricycle?
3 wheels cycle.
Good. So a cycle. Jordy and Jonas. A cycle is just a ringed structure. So cyclic alkanes, all that means is a ringed alkane. Now, we can make propane and we can turn it into something that we call cyclopropane. But something very important happens when we do that. So when I take a look at these things, sorry, this is a little bit of a pain in the butt. In the butt talks.
What? There's a 4-star cut shot.
In the butt talks.
I like that.
I actually don't understand that. Yeah, I wonder why.
Yeah, this is starting to get weird, but that's fine. Okay, let's take a look at this. So I've got propane. Do you agree with me that this is 3 carbons in a row? It's propane and it's got a bunch of hydrogens on it. Perfect, awesome. So what I want to do is I want to turn this into a cyclic compound. So I want to connect this terminal carbon with this terminal carbon. Now if I just connect them the way they are right now, can I?
No.
They can't bond together, can they? What's the problem?
You need to remove the hydrogen.
You need to remove a hydrogen from both of these terminal carbons, right? So when you remove 2 hydrogens, Now we've got an open position for bonding at the carbons. So now I've got my cyclic propane. This is cyclopropane. That's what we would call it. C3H6. So this does not follow the same formula. Cyclic compounds, they follow, oh, there it is right there. Sorry, I didn't know if I had it. CnH2n. Yes, Jordan, Alex, you can go. So cyclopropane and cyclobutane, they are C3H6 and C4H8. So this is the first time that we've kind of deviated away from this idea of that normal alkane formula. Naming cycloalkanes is the exact same thing as naming regular alkanes. The only problem is, when I look at this, is there a beginning or an end to this molecule?
No.
No. Whereas if I had a straight chain, is there a beginning and an end to a straight chain? Yeah, so if I need to number these carbons 1, 2, and 3, which one becomes 1, which one becomes 2, and which one becomes 3?
They all are.
It's not that they all are, but at least right now, there's no way to differentiate them, so you just call one of them 1, one of them 2, and one of them 3. Now, if I have a branch on here, let's say I had a methyl branch. If I had a methyl branch on one of these, can you now define one of these carbons to be carbon number 1?
Yes.
Yeah.
Yes. Which one are you going to define to be carbon number 1? The one that has it attached, right? So we're all of a sudden there's a very simple way. If you just kind of think about it for a little bit, there's a very simple way of being able to name these cyclic alkanes. Since there's no end to a ring, you're numbering at one of the branches. Just start numbering at one of the branches. Number the carbons so that they have the lowest total number still, right? Omit the 1 if there's only one branch on the ring. So what I could say, this is a cyclopropane, but what's attached to the cyclopropane? A methyl group. Do I have to say 1 methyl cyclopropane?
No.
No, because if it's attached here, that's 1. But if it was attached here, that would be 1 as well. So we just say methyl cyclopropane, just because there's one branch.
Say it 10 times.
Methyl cyclopropane.
No,
methyl
fast, fast,
cyclopropane. I can't. I literally can't talk faster than that. I would be the worst rapper in the world. It would be
What's your freestyle?
slow rap. The
Chemistry.
worst slow monotone rap in the entire world.
Freestyle.
Chemistry is awesome, yo, I'm here to say.
Okay.
Okay, let's take a look at this molecule.
Walton versus Edo.
He would win.
I don't know.
He would win. Yeah, he would win big time. He's got way more experience. Did you know that I'm Z-Dog's hype man when he goes on tour?
What?
Yeah, I'm his hype man.
He literally puts like a Costco chain on his neck. It's an actual industrial chain.
Yeah, totally. Yeah.
Oh, he's got so much work.
Oh, so good. So I'm the person that goes on stage first. And I grab the mic or whatever. Yeah, that's right. I'm like, oh yeah, you know what time it is. Z-Dog's in the house. And then I throw the mic to him, and then he stands there. Yeah. Okay, let's get back to actual work. So let's take a look at this. Is this a ringed structure? Yes. Is this a ringed structure? Yes. So we're gonna have cyclo in the name. How many carbons are a part of this ring?
1, 2, 6.
So cyclohexane. Are there any branches on it?
No.
We're done.
Wow.
So this thing is cyclohexane. That's it. There's no branches on here, so we don't have to name any branches. That's fine. What about this? How many carbons are in this ring?
5. Oh wait, no.
How many carbons are in the ring?
Oh, 5.
5, right? So we know it's going to be cyclopentane. Now, what types of branches are on this cyclopentane? We see methyl branches, and how many methyl branches? 2. So I'm going to say dimethyl. But the problem is, you have to tell me where those branches are, because could both of the branches be on that first carbon?
Technically, yeah. That it's not on the same. So like.
No, because what if is there a difference between this and a difference between this?
No.
Yeah.
No.
Yes.
Yeah.
Wait, maybe.
Is there a difference between that and that?
Yeah.
Then you have to. Then yeah, you have to be able to discriminate because of the name.
Discrimination. Why would you just
Whoa! You understand? Discriminate just means tell the difference between, right?
No.
2019.
Come on, roll
Please don't.
1, 2.
Just stop. Okay, which one do you want to be carbon number 1?
Yes.
Right most.
The top one, the top left, the bottom left, bottom right, or top right?
Top right.
Top right, sure. So that's 1. So now we have a conundrum on our hands. Do you know what our conundrum is?
You don't know which way to your calendar.
Which way do we start numbering?
Down.
Clockwise or counterclockwise? Yeah, you have to know how a clock works in order to answer that question. Does everybody here know how to read an analog clock? Like the clock with hands and everything? Can you discriminate?
I don't know how to read one.
Okay, we're going to work on that at practice anyway.
I'm not going to be at practice.
Okay, so should I number counterclockwise or should I number clockwise? Good, 2. So where are the methyl groups?
1, 2.
1, 2 / dimethyl pentane. Dimethyl cyclopentane. Dash, sorry, dash, not slash. Dash. Yeah, you have to be able to discriminate between a dash and a slash and a comma, right? Okay, draw the condensed and line diagrams for ethyl cyclopentane. And then, when you're done that, draw the condensed and line diagrams for 3-ethyl 1,3-dimethyl cyclohexane. Pentane. It really isn't that bad. Where do you always start? At the end of the name, right? Yes, sir. Just start at the end of the name and work your way forward.
The condensed.
Ew, what? Mr. Bolton, I'm having a hard time drawing lines.
Okay. Yep. Oh yeah, you're like literally having a hard time drawing.
I'm so dumb. Me too.
As long as it's very apparent that when one line stops, another line starts or whatever at a vertex, then I'm perfectly So next, line diagrams for 3 No, because I see number your carbons for me.
I did it wrong. I don't think it's Hey, usually it's that to keep your that's not keeping your Voila. If you want to.
What's your piece? What's your
You didn't even stand the yeah, so do the last one.
I'm guessing the one that's broken is the spare. Why did you carry both? Okay.
It's a command.
You're dark, you're not.
Yeah, it's my
Oh yeah. So do you have to take it out?
Yes. No. Yes. But also no. But also. Yes. What about the other one? Yes. What? Yes. That's fine. Yes. Both the Butane.
Oh, I got you.
I actually kind of understand this. This is kind of sort of not really. I just need to like, yeah. I should teach a grade 1 this.
What?
I should teach a grade 1 student this.
Yeah, go right ahead.
Pretty sure they just see the video.
I'm gonna volunteer for Gabe.
You have to volunteer.
Yeah, come.
If you have to, then it's really you're being forced to do it.
It's kind of just work.
Okay, I have what I consider to be the answer for the top question. So that's whatever, you can take a look at it. Okay, draw the condensed and line diagrams. Do we understand why this wasn't called 1-ethyl cyclopentane? Because it doesn't matter where you put the ethyl group, it becomes the number 1 carbon, right? So it's just saying ethyl cyclopentane is fine. Draw the condensed and line diagrams for 3-ethyl 1,3-dimethyl cyclohexane. I want to be very clear, that name, there's something very wrong with this name.
Oh, alphabetical order. No?
Nope.
A, C, D, E.
So, no, but the di doesn't come into play, right? It's ethyl and methyl, so E comes before M. I understand di and tri and whatever, but the prefixes on the prefixes don't matter.
Okay.
It's just the ethyl, methyl, propyl, butyl, that kind of stuff. So that's not it. Let's draw it out and let's see what's wrong with it. Does it make sense to draw a line diagram first or a condensed diagram first? Okay, are we happy with line diagrams? Okay, so what's cyclohexane look like? Looks like a cyclohexane, like a hexagon. Okay, and then let's talk about our numbers. Which carbon do you want to be carbon number 1? Top? Top?
Top right.
Top right?
Top left.
Bottom right?
Top right.
Bottom?
No, that's right.
Top right.
Bottom middle.
Top right, sure, whatever. 1. Now, which way do you want to start numbering it? Clockwise or counterclockwise? 2, 3, 4, 5, 6. Okay, let's try this out. What's attached to number 1? There's a methyl group, and then what's attached to number 3?
Ethyl.
An ethyl and a methyl group. But here's the problem. Did anybody notice our problem?
Yeah.
What do our numbers add up to be? You got 1 1 and you got 2 3s. So that adds up to being 7. Is there any other way you can number this molecule so that you get a lower number than that?
The other way.
Do it on the inside.
Turn the
So the proper name for this should be 1 ethyl, 1 3 dimethyl cyclohexane. Do people still play hangman with their friends every once in a while?
Not with your friends.
Yes, not with their friends?
No.
With random people online? Or
Yeah.
teachers?
Yeah. No. Yeah.
Okay.
Let's play it. Let's play Hangman.
So, if you ever want to play hangman with somebody, play hangman with 1 ethyl, 1 3 dimethyl cyclohexane.
Who the heck was that?
I don't know if you're like.
Where did that come from? He's so lazy.
Do it with dimethyl.
But the rule is,
Yeah.
he has to be hanging by whatever cycle A.
Yeah. Okay, then let's do the condensed diagram. C, 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 C. And we got 1 carbon, 1 carbon, and 1 ethyl. And then you just fill in the hydrogens, right?
Yes, sir.
Perfect. Are there any carbons in here without hydrogens on it?
Yes.
Yes. This carbon has no hydrogens because it already has 4 bonds on it, right? Good. Okay, I want to give you...
Time to relax and
No, certainly not time to relax. No.
Not until after the diploma.
I tried. Well, I did my best.
You do. What you doing?
How about you make it an hour marker?
You want to your hands?
Walton, I know you need some extra help.
I do need extra help.
And you're denying.
Okay, so
This is childhood.
what I would like to do is I would like you to work on this, but I want you to understand that this is not for marks. I just want you to do this and try it out. See if you can understand these principles, and then tomorrow I'm going to toss up the key, and then we're going to move on to something called alkenes and alkynes.
No quiz, please. No quiz. Monday, please, let's have a relaxed weekend. We already had such a tough weekend.
I know.
The dance is on Thursday.
Yeah, the dance is on Thursday.
Oh, the dance is on Thursday.
So I'm gonna be up until like 1 o'clock down below.
So let's do the quiz on Tuesday.
Yes.
That's good, man. Tuesday. Is that okay?
Can I get a high five before you get the dance?
Yeah, how about we just make it Tuesday? Or Thursday? So that
No, we're not going to make it on Tuesday.
No, I just do it. Not the dance.
No, because
I the dance.
because I want